Welcome to edupediaworld.com. You're watching the videos on areas of parallelograms and triangles. So in this video we'll discuss and solve some of the important questions which are very important questions from the exam point of view. So you have to watch this video very carefully. So let's discuss the question 1 now. The question says that in figure ABCD is a parallelogram in which AE is perpendicular to DC and CF is perpendicular to AD and AB, so this line is given 16 centimeter, and AE it's given 8 centimeter, and CF it's given 10 centimeter. So we need to find AD. So let's see how we can solve these type of questions now. So all we know that area of parallelogram can be written as its base into corresponding height, right? So if we take base as DC, then its corresponding height will be AE. Corresponding height means the height which is falling on the base DC. So we can see clearly that if DC is the base, then the height, the altitude is AE. Now in parallelogram, opposite sides are equal and parallel. So if this AB is 16 centimeters, so this is also will be 16 centimeter, right? Now we can write this as 16 and A is 8. Now similarly, area of parallelogram can also be written as, if we take AD as the base, FC as a height, so it can be written as AD into FC. So now whether we write AD into FC or DC into AE, the area will remain the same. So we can say that AD into FC can be written as 16 into 8, right? Now we need to find AD. However, FC is given to be 10 centimeter, so we can write 10, 16 into 8, right? Now AD will be equals to 16 into 8 upon 10. Now so 16 times 8 will be 8 6 are 48. We need to carry 4. 8 1 is 8 plus 4 is 12. So we can write this as 128 upon 10, so which is 12.8 centimeter. So this is how we can solve these type of questions. So let's discuss the next question of this video, question number 2. Now the question says that if E, F, G, H are respectively the midpoints of the sides of a parallelogram ABCD, show that area of EFGH is half area of ABCD, right? So let's see how we can solve this question. So let's say we have a parallelogram like this. So this is a parallelogram A, B, C and D. Now so let's say this is a midpoint, so this is a midpoint, so this is a midpoint, this is a midpoint, right? So let me use this pen now. So let's say we join these midpoints like this, like this, like this, right? So let's say if it's E, F, G and H. Now we need to prove that area of EFGH is half the area of ABCD. So let's see how we can solve this question. So let's say if we draw a line like this, so we can write, we can see clearly that area of GHF will be half the area of DCFH, right? So if these are the midpoints, then this area will also be half the area of the complete parallelogram, right? Okay, now so this is be 1. Similarly, we can write area of EFH will be half the area of ABC, FH, let it be 2. Now, why these two areas are half? Let me discuss now. As we have read the theorem that if in a parallelogram and a triangle they have a same base and they are between the same parallel lines, the area of triangle will be half the area of parallelogram. So in this part you can see that area of GHF, they have a same base. The base is, you can write base is HF, same base, right, and they are between the same parallel lines CD and HF. Similarly, for this area of EFH, they have a same base HF again and the parallel lines HF and AB. So area of triangle EFH is half the area of ABFH, right? So this is how we can use the theorem. Now we can say right now, adding 1 and 2, we get area of GHF plus area of EFH will be equals to half area of DCFH plus half the area of ABFH, right? Now area of GHF, this area plus this area will make the area of a parallelogram. So we can write area of GHF plus area of EFH as area of EFGH, which will be equals to, now, so half, we can take half as common out, so it will come out to be area of DCFH plus area of ABFH, right? So area of EFGH will be half. Now area of DCFH plus area of ABFH, it will be complete area of ABCD, parallelogram area, right? So it can write area ABCD. So this is how we can prove that area of EFGH is half the area of ABCD. So this is how we can prove these type of questions. So let's discuss the next question, question number 3 now. The question number 3 says that P and Q are any points lying on the sides DC and AD of parallelogram ABCD. We need to prove that area of APB equals to area of BQC. So first we need to draw a parallelogram. So let's say we have a parallelogram like this, A, B, C, D, right? Let's see, we have a point P on DC. So this is the, let's say this is a point P, and we have a point Q on AD, right? So we need to show that area of APB is this triangle and area of BQC right, they should be equal. Now so let's see how we can prove this. So we can write area of APB is half the area of ABCD. So why half? Since they have a same base AB, you can see the triangle APB, it's on the same base AB, and parallelogram also have a same base AB, right? And same parallel lines AB and CD, so they lie between the same parallel lines AB and CD, right? So that's why they are half. Similarly, we can write area of BQC is also half the area of ABCD. Let it be first and let it be 2. Why? Again same reason, they have a same base BC and same parallel lines BC and AD. You can see this is a base BC, and these are the two parallel lines BC and AD, so they are half. So from 1 and 2 we can say that if right hand side, both the right hand side they are equal, left hand side should be equal. So from 1 and 2 we can say that area of APB is equals to area of BQC. So this is how we can prove these type of questions. So let's move on to the next question, question number 4. Now the question number 4 says that in figure, P is a point in the interior of a parallelogram ABCD. So first part is we need to show that area of APB plus area of BCD is half the area of ABCD. So let's see how we can prove this. So if we can draw a line through P parallel to AB, so we can write over here, draw a line through P which is parallel to AB, right? So let's see how we can prove this. Now we can write area of APB will be half the area of parallelogram. Let's say these points are E and F. Since this line is parallel to AB, so this will also be a parallelogram. ABFE will also be a parallelogram. So we can write area of APB will be half the area of parallelogram ABFE. Why? Because they have a same base AB and between same parallel lines AB and EF, right? So let it be first. Similarly, you can write area of PCD is half the area of, let's say, EFCD. Why? Same reason, they have a same base DC and between same parallel lines EF is parallel to CD, right? So let it be 2. So if we add, let's say we can write adding 1 and 2, we get area of APB plus area of PCD will be equals to half area of ABFE plus half area of EFCD, right? So we can write then area of APB plus area of PCD. Now if we can take half common out, so it will become area of ABFE plus area of EFCD will be this area plus this area, complete area. So it will come the area of ABCD. So this is how we can prove these type of questions. So let's discuss the second part. Now for second part we can say, let's say we need to draw a line, let's say like this. Now, so next part says that area of APD plus area of PBC should be equals to area of APB plus area of PCD. Now we need area of APD, so means this area and this area, right? Now let's draw a line parallel to this AD. So again we can write, draw a line through P parallel to AD, right? So again we can write area of APD. Now So let's say again this point BO and G, we can write half the area of AOGD, right? Same reason, because they have a same base AD and they are between same parallel lines OG and AD. Similarly, we can write area of PBC is half the area of OBCG. Same reason, they are same between same base BC and between same parallel lines OG and BC. So if we add again these two, we get area of APD plus area of PBC now will be equals to half the area of now. So if you see properly, area of AOGD plus area of OBCG will become area of ABCD. So we can write then area of, let's say, area of APD plus area of PBC as half the area of ABCD, right? So let it be 3 and let it be 4. So we can write again that from 3 and 4 you can write area of APB plus area of PCD is equals to area of APD plus area of PBC. So this is how we can prove these type of questions. So let's move on to the next question, the last question of this video, question number 5 now. The question number 5 says that in figure PQRS and ABRS, so PQRS means this and ABRS means this one, are the parallelograms. X is any point on the side BR, so we need to show that PQRS equals to area of ABRS. Now, so we can write area of PQRS is equals to area of ABRS. So why they are equal? Because if you can see properly, they have a same base SR, right? So let me draw with another pen. So if this is P, Q, R and S, so this one will be A, B, R, S. So they have a same base SR and they are between same. So parallel lines, it can be BP is parallel to SR. So that's why the area of PQRS equals to area of ABRS. Now, so let's see how we can prove the next part. So we need to prove that area of AXS equals to half the area of PQRS. Now, if you can see properly, area of AXS equals to half the area of ABRS. Why? Because they are between the same base AS and same parallel lines. So parallel lines can be AS is parallel to BR, AS is parallel to BR, right? Now we know that area of PQRS equals to area of ABRS. We have proved above, right? We have proved above. So we can, this implies is we can write area of AXS is also half the area of PQRS. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.